Hey, good morning. This video is for those of you who missed class on Monday, March 28th. We are going to be in lesson 2.1 in populations and resources, and this is titled Reproduction and Energy. Go ahead and do your warm-up. The warm-up shows an image of tree frog tadpoles about to hatch, and the prompt is, what ideas do you have about what could cause the number of births to increase in a population? Go ahead and pause the video and fill this out. All right. So we know the moon jelly population in Glacier Sea increased because there were more births than deaths since 2000. So now we need to figure out if there was more births because the births increased or because the deaths decreased. So this ties back to the claims that we have now. The claim number 1 shows that the population increased because the number of births increased. So we see in the model before 2000, we've got 2 jellyfish deaths and 2 jellyfish births. So that means it's a stable environment population. But then after 2000, there were more births than deaths. The number of deaths stayed the same. So that's claim number 1. Claim number 2 says the reason why the population increased was because the number of deaths decreased. So again, same model for before 2000, but after 2000, it shows the same number of births, but the number of deaths decreased, and that's why there was an increase in population. So we need to do a little bit more exploration, a little bit more, we need more data, we need more evidence in order to make a decision which claim we want to support. So our chapter 2 question is, what could have caused the births to increase or the deaths to decrease in the moon jelly population? We've got a vocabulary word we're going to be using. It's reproduction, and it is the process of creating offspring. Now, not to be super graphic or anything, but reproduction is just more than the one act of reproduction. It's the entire process. So everything leading up to before, during, and after producing offspring. And you'll understand what I mean after we read the articles that we have for today. You're going to read all about reproduction and energy in this article set that we have. And I'm going to read and annotate the reproduction and energy chapter 1. You guys are going to go ahead and read the rest of them. So if you go into Schoology, go to your courses, and in science, our today's folder, you're going to see that I've got this PDF, Reproduction and Energy. I'm going to read this first one, chapter 1, and it's just kind of an introduction article to reproduction and energy, and I'm going to model how to annotate that. And then you are going to read chapter 2 about sockeye salmon. Chapter 3 is about emperor penguins. Chapter 4 is fireflies, and chapter 5 is about elephant seals. Okay, let me start off, first of all, by demonstrating how to annotate this article so you follow along and do what I do. All right? Okay, so first, I always like to look at my pictures first. So I see that there's this great picture of 2 elk, and the information underneath the picture says male elk fight one another for the chance to reproduce with female elk, and that fighting takes a lot of energy. Well, I'm going to actually make that a little bit darker. Fighting takes a lot of energy. I want to highlight this. Good grief. I'm going to highlight this here because I want to make sure that I understand that this article is about reproduction and energy. So this is the first time that I see that anything having to do with reproduction, anything having to do with the process of reproduction requires energy. So coming in here to chapter 1, energy requires, doggone, I don't want that. Energy requires energy. Reproduction requires energy. Sorry, you guys. I'm trying to figure out how to, I want that even smaller. Let's see. I'm going to go like this. And let me see now if this works. Yeah, that's what I want. Okay. Sorry. Let's go ahead and start. You guys do what I do, okay? Reproduction is a lot of work. So, first of all, it tells me it's a lot of work. So, I want to know why it's a lot of work. And they're going to list off several reasons why reproduction is a lot of work. Some organisms travel. Hang on, I've got an alarm going off here. Some organisms travel thousands of miles to find a mate, the right place to lay eggs, or the right spot to give birth. They might work hard to attract mates using songs, movements, and other displays. Other organisms might fight fierce battles to win their mates and the chance to reproduce. Often, this is just the beginning of the job. So this is just leading up to actually reproducing, male and female. After reproduction occurs, then we still have more of a job to do. Many organisms work hard to protect their eggs, find food for their young, and do everything else that may be required for successful reproduction. So remember that very first sentence says reproduction is a lot of work. Look at, we've read about 6 different ways reproduction is a lot of work. No matter what an organism goes through to reproduce, the process requires lots of energy. So let's go ahead and highlight that. The process requires lots of energy. In fact, for many organisms, reproduction requires more energy than anything else in their lives. Now, I'm going to stop here and I'm going to just do a little bit of annotating. When we talk about reproduction, I don't know how much you guys have background information. You may have had a dog that's had puppies, or a cat that had kittens, fish that had babies, or maybe you just have some background information about any other organism that has had babies or has reproduced. But I wanted to put something up in the margin here just to kind of help me make a connection to this. So in class we talked about humans. So humans, do you know how long a human is pregnant for? And a lot of people say 9 months. We say that a lot, but it's actually 40 weeks. Okay? Now, if you do the math, 40 weeks is actually 10 months. So a woman is actually pregnant, full term is 40 weeks. And of course, you can go anywhere from 38 to 42 weeks. That's normal pregnancy. But then let's think about after the woman has the baby, is that process of reproduction done? In other words, can the baby fend for itself? And it cannot. We did a lot of talking in class about at what age do you think a human being is able to be self-sufficient, is able to sustain itself. It can take care of itself. It does not need its parents. And we kind of all agreed that maybe at age 13, you're able to get up and make your breakfast and make dinner and make sure that you can get yourself showered and do whatever it is that you need to do to live your life. But chances are you don't have the resources or the money that's required to get all of those things. And so they thought, well, by the time a person gets a job, technically, if you have your own job, you're able to get all the resources that you need. But you may not be able to find a place to live. Okay, so maybe you have to be a little bit older, get a little bit better job. So we all agreed probably bare minimum would be 16 years old at the very minimum, but probably more like 18 or 19 years old. So from birth to, let's say, 18 years, that parent requires energy to make sure that their offspring is able to reproduce on their own, grow up, do their own thing, right? So it says reproduction requires more energy than anything else in their lives. We get that. We've got some background information there. Now look at the next sentence. It says some don't even survive. Reproduction requires so much energy that these organisms reproduce and then die. That's the case with the sockeye salmon. You guys will read about that a little bit later. Whether reproduction is relatively easy or extremely difficult, every organism needs energy in order to reproduce. That's very important and something that we need to make sure that you understand. There is no organism that can reproduce with little energy or zero energy. They all require energy. Without energy, there can be no reproduction. Organisms get the energy they need from energy storage molecules such as glucose, starch, and fat. Now, energy storage molecules is something I'm going to actually have you guys underline that as well. Energy storage molecules. You know how I like to abbreviate. We're going to abbreviate energy storage molecules, or ESMs, and there's 3 of them. There is glucose. What's another name for glucose? Do you know? I wish I could zoom in a little bit, but I can't. So sugar, glucose, starch. Starch is in like potatoes and rice. Starch can be stored in the cell, and then later it can get used as energy. Like if you are getting ready to run a race or whatever. A lot of times coaches will say, eat carbs before you have some kind of a competition, because that gets stored in your body, and then you can turn around and use that energy later on. So carbs, I don't know if you guys want to write that in, you can. So glucose is sugar. It's not letting me write. Okay, glucose, starch, and fat. And so we'll go ahead and put fat down here. Now, I want you to write that in the margin, because we're going to be talking a lot about ESMs. And in fact, ESM, energy storage molecule, that's one of your vocab terms. You need to know about this, get really, really used to it. So you need to know what are the 3 ESMs. It's glucose, starch, and fat. It says these molecules store energy that can be released in the bodies of organisms when they need it. So humans store energy, all organisms store energy, and then when they need it, they can release it. Now, plants and other producers, let's go on to the next page. Done. Sorry. Let me get over to the next page here. Plants and other producers can make their own energy storage molecules. Do you guys know that a plant or another producer, like algae is a producer? There are some bacteria that are their own producers. A producer is just that. It means that you can make your own food. And in the grocery store, I'm going to write producer. In the grocery store, you know the aisle or the section in the grocery store where all the fruits and the vegetables are? Do you know what they call that department? They call that the produce department, because it's made from producers. Okay? So producers make their own food. But other than that, other organisms, and they make their own food, I should say this, through something called photosynthesis. And we're going to talk really a lot about photosynthesis later on. But other organisms can't do that. They have to get energy that they need, ESMs, from other organisms. Okay? What is food really? Food is the body part of an organism that contains molecules such as energy storage molecules. And what I told the kids in class, every time you see this energy storage molecule, I want you to annotate ESM, because you've got to get used to writing that ESM and know what an energy storage molecule is. Remember, it is glucose, starch, or fat. So food is the body parts of organisms that contain molecules such as ESMs that other organisms need. Now, I am going to pick a highlighter. I'm going to change the color and I'm going to go here. Consumer population is the term ecologists use to talk about a population that eats other organisms. So consumer population. Do you remember what I told you guys? Amplify does not use predator prey. They use consumer population and resource population. I am sorry, my handwriting is just horrible. Sorry. Consumer population is the predator. Okay. And then it says ecologists call the population that is eaten for food a resource population. Let me grab my highlighter again. Resource population. So the resource population is the prey. Again, vocabulary terms that you're going to need to know. Every consumer population gets its energy storage molecule from a resource population. I'm going to switch back to my yellow and highlight that again. Every consumer population gets its energy storage molecules, ESMs, from a resource population. To learn about some specific populations and how they get the enormous number of energy storage molecules they need, let's go ahead and put ESMs again. Whoops, sorry. Energy storage molecules, ESMs, that they need to release energy for reproduction. Read one or more of the chapters that follow. Take a look at this graphic here. Here's my resource population. Remember, this is the prey. And the energy storage molecules will travel from the resource population to the consumer population, which is the predator. Okay? So now you're going to go ahead and finish the article, all of the articles. So when you're come back in here, now you're going to read about sockeye salmon, emperor penguins, fireflies, and elephant seals. And look, they've got this graphic at the for each one. So it shows the resource population and it shows the consumer population. So for like sockeye salmon, I wish I could zoom in here and it's not letting me. But the resource population is the shrimp. The consumer population is the salmon. Remember, every time you read about ESMs, write ESM in the margin. And really, you're trying to answer the question, what does it take? What kind of energy, or how is energy tied into reproduction for all of these different organisms? Okay, that is due in class tomorrow. All right, you guys, take care. Let me know if you have any questions.